Okay, now that we've talked about limiting reactants, we now have to apply this concept to solving an actual chemistry problem. So here is the question. 21.56 grams of hydrogen reacts with 87.32 grams of oxygen. What is the limiting reactant? How many grams of water will be produced? And how many grams of the excess reactant will remain? So to start off, we're going to treat this like any other stoichiometry problem. Step one is to write a complete balance equation. And then step two, I always advise you to label what you're given and what you're looking for. So step one, there's our complete balance equation. Step two, we're given 21.56 grams of hydrogen, 87.32 grams of oxygen, and we're looking for the amount of water. So here we have two givens, but that's okay. We're going to solve this as two separate problems. So the strategy here is ignore the oxygen for right now, and let's go ahead and solve for the amount of water that we can produce based on the given amount of hydrogen. So a chemical equation, the 2-to-2 ratio, is only good for moles. So there's nothing new here. Like all the other stoichiometry problems we've been doing, the first thing is we're going to convert grams to moles. So I'm showing that here. Now remember, it's diatomic, so it's 2.02 is the molar mass of hydrogen. Step four was set up a ratio. From the equation, for every 2 moles of hydrogen, we're going to produce 2 moles of water. So that's where the 2-to-2 ratio came from. And then the molar mass of water is 18.02. So doing the calculations, we can expect to produce 192.3 grams of water from reacting 21.56 grams of hydrogen. The question is, are we going to actually produce 192.3 grams of water? Well, to answer that, we have to now ignore the hydrogen and let's figure out how much water we can make based on the oxygen. Very similar to the previous video where we talked about producing sandwiches from bologna and bread. So I took the mass of oxygen, 87.32, converted to moles, divided by 32.0. Remember, this is diatomic. Molar ratio is for every 1 mole of oxygen, you can expect to produce 2 moles of water. Using the molar mass of water, 18.02, the calculations equal 98.34 grams of water. So the question is, are we going to produce 98.34 grams of water, or are we going to produce 192.3? Very similar to the sandwich example, we're either going to produce 24 sandwiches or we're going to produce 16 sandwiches. Well, in this case, we're not going to produce 192.3 grams of water because we don't have enough oxygen. We only have enough oxygen to produce 98.34 grams. So this value, 192.3, really doesn't ever exist. It's a theoretical calculation telling us how much water we can produce based on the amount of hydrogen. But this is never going to happen because we're going to run out of oxygen. We have enough oxygen to make 98.34 grams. So 98.34 grams of water will be produced because there is not enough oxygen to produce 192.3. This makes oxygen our limiting reactant and hydrogen is the excess reactant. So we go back up to the top, and that's how we know then that the amount of water that's going to be produced is 98.34 grams, and that is because we're limited by the oxygen, which makes oxygen the limiting reactant. The next step then is we have to go back and answer part C. How many grams of the excess reactant is going to remain? So here's how we're going to solve for the amount of excess reactant that remains. I just want to remind you that this really isn't any more complicated than the example we did with the bread and the bologna. So we've already established in the previous work that hydrogen in this case is going to be the excess reactant and oxygen is going to be our limiting reactant. So as a previous video showed, we want to set up a ratio between the limiting reactant and the excess. So the amount of oxygen, which is our limiting reactant that we have available, is 2.729 moles. And that is a solution to part 3 in the conversion. So if you take 87.32 grams, convert to moles, you get 2.729 moles of oxygen. That is how much oxygen we have available to react. The question is, how much hydrogen is needed to react with that amount of oxygen? So as we talked about earlier, we're going to set up a ratio between our limiting reactant, which is oxygen. So we have 2.729 moles of oxygen. I want oxygen to cancel. The ratio of oxygen hydrogen from the equation is 1 to 2. So for every 1 mole of oxygen, we're going to need 2 moles of hydrogen. So completing the math, we see that we need 5.458 moles of hydrogen to react with the 2.729 moles of oxygen. The question now is, how much hydrogen is going to be left over? Well, we need 5.458 moles of hydrogen, and if it's in excess, then we must have more than that available. So go back and look at the previous slide or work that we did. In step 3, when we converted 21.56 grams of hydrogen to moles, it equals 10.67 moles. So in this particular reaction, we have 10.67 moles of hydrogen available to react. We only need 5.458 moles. So to figure out the amount that'll be in excess is simply going to be a little bit of a subtraction problem. We're going to go ahead and take a look at the amount of hydrogen that's available, which is 10.67 moles, and the amount that we need, which we calculated up here in this ratio, is 5.458 moles. So if we take 10.67 moles and subtract from it 5.458 moles, we get 5.212 moles of hydrogen that is in excess. Now remember, when you subtract numbers in science, we're controlled by the least accurate value. So our final answer for this particular step has to show 2 decimals, so that it's 5.21 moles. So 5.21 moles of hydrogen is in excess. But remember, the problem asks for how many grams? Well, that should be an easy step for us because you all did quite well in this section. We're simply going to be converting moles to grams. So I take 5.21 moles of hydrogen, and I convert that to moles, remembering that hydrogen is diatomic, so it's 2.02. So the answer to part C is 10.5 grams of hydrogen are in excess. And that's pretty much how you do an excess reactant problem.
Okay, that concludes this video. If you have any questions, you can always get a hold of me in Google Classroom through Google Hangouts, or you can also contact me via email. So until then, everybody, stay healthy and stay well and take care.